Okay. Welcome to the Sprint 14 report. Just wanted to go over what happened in the sprint for the community. Marianne, next slide, please. There we go. So there were several things done. In the middle of the sprint, we had the design summit, which took away probably at least a week and a half from the whole team, maybe even the better part of 2 weeks. There wasn't as much done as we had hoped, but there was actually kind of a lot done. So next slide, please. All right, so as I mentioned, we had almost 100 pull requests merged in the sprint, which I think is quite amazing. 40 of them as bugs and 9 as enhancements, and 35 were technical debt, 6 were refactoring, and 11 were test. I think the sprint before we had something like 150 or 160. I don't have the number in front of me, but it was large. But at that sprint 13, we had the whole group focused on just coding rather than getting prepared for the summit. Next slide. So, as I mentioned, we had our first design summit. There were over 70 people attended. The design summit was split into 2 halves. There was a design track and there was an extend track. I would characterize the design as more for engineers and the extend more for users and integrators. The slides are available at the URL there. And what else can I say? It was really amazing to see the first design summit have so many people attend, as well as so much interesting content being presented. It was really a great way to kick things off. So looking forward to the next one on that. Next slide, please. Ready?
All right.
Yep. Take this one.
So the sprint, Foreman's mostly been focused on some of the planning, a little bit of design work around the modeling of the providers, the configuration provider being the foundation which Foreman will be built on top of. There's not a lot of coding yet, no PRs around this at this time, but we wanted the layout, which is a slide showing kind of the buckets of work that we see, how we want to address them. I don't really have them into sprints at the moment, but hoping to work on that next as well. But we've also had a little bit of input on the pluggable provider side, work with that team a little bit. And so we want to be able to use that architecture with these providers as well. So we're hoping to kind of make more progress on that in this coming sprint. That's not a whole lot on that. You can go to the next slide, please. And I'll actually run through this. Bill, jump in if I go off track. But so we're finalizing the PRs here, the modeling side, which is the kind of orchestration pieces that'll support both cloud formations and heat. And then we have PRs, or we'll have PRs for both cloud formation and heat modeling side, as well as being able to refresh and pull in this data. In this sprint, we also started the design work and discussions around how to deal with template parameters. And they really fit well into the service dialogues that we have today, but we need to enhance those a little bit. And you see the different providers support different types of parameters. So min, max, length, and values is one of them. Amazon has the concept, or Cloud Formations has the concept of a regular expression pattern, but Heat actually allows for multiple statements like that, which we don't support today. So that might be an early limitation, but we're aware of it and deciding how best to expand that. And then, the ultimate goal is to be able to take a template that has parameters defined and generate a service dialog from that automatically, and then a user could customize it as they see fit. Ultimately, getting into the service integration where the templates would be defined as a service linked to the service dialog that we create in the previous step, and be able to order and deploy those templates. So that design work for service integration will start in this sprint. And then an interesting thing that Bill pointed me to were these template generation tools that exist for both products, where today generating a template can largely be a manual process of typing out a JSON file or something, which is not an easy way to get bootstrapped. So there are actually projects on both sides that you can point at resources. It will generate an initial template that you can then use to refine and add parameters. So just started researching those to see if we can use those in the project as well. Those look promising. Next slide. Do you want to take this one?
So for the automate stuff, we are actually trying to add version control. And one of the first steps that we have to take is, see if we can convert all of our active record models so that they can be accessed from the file system. Once they can be accessed from the file system, then we can actually easily start putting them into Git. So in our code base, there are a lot of places where, we are making active record calls to get information from the automate model. So one of the first things that we started to do was to, start working from the UI side by looking at, the different active record classes that the UI controllers use, and start fixing or, seeing how much we'd have to change and not be very disruptive and, change the whole thing. So some of the things that we came across were IDs. For example, the IDs in active record, they are all basically integers. And there is things that we use on the IDs where we actually compress the IDs so that we can actually store them as tree nodes and stuff in the controller. So we had to actually change, and when you go to the file system, there is really no notion of an ID. So we had to come up with fake IDs, which actually basically look like the path, but then we ran into an issue where if you use paths, it actually runs into routing problems in the controller. So we had to actually create the fake IDs, which help us easily locate the data in the file system, but also don't break the existing functionality that's there. So we got the controller and the UI working going, and then we started looking at some of the validations which actually are provided by active model. And we started adding the validation stuff where we can actually check for uniqueness of an instance name in classes and uniqueness of method names and namespaces, all those things. The main goal here is to actually stay as much as we can backward compatible with all the existing stuff that we have so that we don't end up making massive disruptive changes all over. So pretty much at this point we have gotten the Automate Explorer, the Automate Engine. I'm still working on the specs. The specs still have a lot of open, corner cases that we need to fix. Then there is the import, export, and provisioning. So I think once we go to resolve all of these issues, we would actually have a pretty much collected all the requirements from the active record side that we need to implement in the file system layer. And then once we have that, we'll actually start designing that piece and maybe creating PRs. And then once we have that, eventually move to Git. So that's the plan.
Cool. Next slide. All right, so this is one of the enhancements that we got in kind of at the end of this sprint, was support for clone option overrides. And what this allows us to do for, take the cloud side, for example, we collect the items from the dialogues or from provisioning scripts that have modified the options for a provision task, and we create clone options, which we then pass to the provider. The use case came up where someone needed to be able to attach additional block devices when they were provisioning an OpenStack VM. So we started looking at how best to do that, what it would take to support parsing that data. And we realized that it would be a lot easier for us to expose this option where we were told that they could actually create the block storage ahead of time, have the ID. They just needed a way to pass it down to the provider. So by opening up this override, we allow them to define anything that can be passed to the provider, supply it in this clone options hash value, and we merge it into what we're passing along to the provider. So in the example down below, you can see that basically something we couldn't have supported before, or we would have had to implement ourselves. We can now give the user from an Automate script the ability to define any type of block device, really any parameter that we don't support today can be passed along to the cloud provider. So this worked great. There's another use case we had where we weren't collecting the Nova networks, but during provisioning in Automate, they could detect those or retrieve those values and pass those along. And we figured out a way to do it to kind of hack around the system and add them, but not link them to the provider. So refreshed it and remove it. And this ends up getting around all of that by at provision time, when the script runs, query the system, find the networks, decide which ones they want to pass along, and then they just follow the parameters that they need to pass as defined by FOG or the Amazon gem. So this actually is nice, allows for us to support any properties that we don't officially support today. And then ultimately, if things become useful enough, we can adopt them into the product, and maybe some of those won't be required. But we put a talk topic together around it to define it a little better. And I'd say that the one thing here is that it is an override, so we log the clone options that we would pass and then merge in the values from this key and then relog the entire clone options again. So if somebody changes something, there is the ability to break the provisioning here as opposed to what we would have passed without this value. So it does have a lot of power, but it's also can expose some vulnerabilities if people start putting in improper values. So hopefully with the logging, we'll be able to trap those easily. But this also is supported from the infrastructure side as well. It's probably a little harder there for how we're integrated with the providers, but we're looking at using this for adding the same type of disk support to Rev that we support with VMware. So that's probably one of the uses coming up. I think it's pretty useful. I think it'll be quite helpful for the field. So cool. All right, next slide.
All right, so one of the main features that was added for provider support during the sprint is that ManageIQ now supports connecting to OpenStack APIs over SSL. I think this was being worked on last sprint and finally made it in. Being worked on sprint 13 and finally made it in sprint 14. It's a feature that's been requested many times. The main challenge here was the fact that there are so many different ways to configure SSL for OpenStack, where SSL termination is happening. Either it can be set up to happen at the OpenStack services themselves, like right in the Python code, or some people are setting it up with proxies to terminate SSL. And they don't always change the port for the SSL connections, where most people are used to seeing HTTP turn into HTTPS or port 80 turn into port 443. A lot of the OpenStack services will just keep the same port for SSL and essentially hide non-SSL connections that way. The way we implemented this is first we try non-SSL. If we get an error, we we fall back to SSL, which is kind of, it seems reverse, but it was the way we could generate an error and figure out, is this actually an SSL connection? It's important to point out that we're using a setting to disable peer verification on the SSL cert. It's kind of equivalent to saying clicking the I accept the risk button in Firefox. But we are working on a kind of a larger story around working better with self-signed certificates. This is, something that a number of people on the team are focused on. Keenan Brock is the one that usually leads the charge here, but we're trying to figure out, some better strategies around this. But for the moment, we are avoiding peer verification on the certificate. That's pretty much it for provider support this sprint. Next.
Okay, so this past sprint, I did quite a bit of work on trying to speed up some specs. As you can see, the big thing that I did was I looked for places where we're seeding, particularly seeding classifications table, or seeding the I believe dialog table was another big one. So I only changed 4 files and got those specs to working, but that alone knocked about 25 seconds off the 30 seconds off the time. So with a little bit of change, I got about a 34% improvement. I searched through the rest of the code, and there's another 70 more locations where we're calling seed. And I say not including MIQ region seed because we do that alone about 80 times, but those really aren't all that expensive. So there's a lot of opportunity here. I know that a lot of the seeds that are being called in those 70 locations are done in before blocks. So they may affect entire spec files or a number of examples. So I'll probably be looking into those in the upcoming sprint. Next slide.
Okay, so last sprint, we already had Ruby 2.0 green on Travis, but we had a lot of untested code that I wanted to verify. So I did a lot of VM scanning and other exercising of the code base with Ruby 2.0. And now that's all working. So at this point, we need a larger audience for Ruby 2.0. So we need to work on upgrade docs for developers and getting the appliances ready for Ruby 2.0, the CentOS appliance. Along the way, we deleted a lot of patches and other areas of code we no longer needed. Aaron was able to get some of the patches on our Rails fork upstreamed and backported, including the truncate and the timing of the record instantiation. And while looking at some of the patches, I noticed there were a few different places where we were doing a lot of duplication of hashes. So one of the changes was to improve small amount of performance in the VM compare screen. That was kind of related to the patches. That's about it. Next slide.
Okay, this sprint, Jerry added support for XFS version 5. That's on top of the support for XFS version 4 that was delivered in the previous sprint and demoed in that sprint demo. Most of the differences between 4 and 5 are internal, and there's really no usable enhancements that would be seen outside of our code. Essentially, this is a proactive support for this version, so once it starts to be more widely used, we just won't fail. So hopefully that will head off some issues going forward. And basically that's it for this sprint.
Rich, is there any update on the ReFS front?
Yeah, Mo seems to be making good progress. However, it's still in the form of investigation, so there's no hard code that fits into our current policing scheme. He has code that will essentially examine discs and dump out stuff, so he can clean successive layers of but from what I've seen, he's gotten further than other people I've seen who've actually posted their results on the web when I was doing some research, so he seems to be making excellent, good progress.
Okay. I don't think that there are any more slides. Are there, Marianne? Next slide. All right, well, no?
It gets an uncle.
That was the last slide.
Oh, last slide. So I'll just open it up to questions and comments at this point. All right, pretty quiet there from the audience. Okie doke. Well, if there are no questions or comments, I guess we'll close out this Sprint 14 report and start looking at Sprint 15, which we should be demoing 3 weeks from today, unless it runs into Thanksgiving. So I don't think so. So we'll do it at that point. Very good. Thanks, everyone.